Hi, I'm Mina.
And I'm Yules.
Thanks for tuning in to Artificially Informed.
So, imagine a perfectly evolved flying insect.
Okay.
It spends its entire early life, navigating this really complex, dangerous world. And it's relying on this highly sophisticated, high-resolution vision to find exactly what it needs.
Right, it needs to see to survive.
Exactly. But the absolute second it lands on its target, which is a host animal, it does something completely wild. It physically sheds its wings.
Yeah, the deer kicked. It's fascinating.
It is. And even crazier, it actually downregulates its own DNA to intentionally lose 50% of its vision gene activity.
Wow.
I mean, it literally uninstalls its own biological software for sight. It permanently trades its ability to perceive the wider world just to save energy for immediate consumption and survival.
It's basically the ultimate evolutionary trade-off.
Right.
I mean, why pay the massive metabolic cost to understand the world around you when you can just, well, blindly consume what's right in front of your face?
Exactly. And, the reason we are starting today's deep dive with the bizarre biology of the deer kid, and because as I was looking through today's intelligence briefings and scientific journals, I just couldn't shake this profound sense of deja vu.
Oh, really? How so?
Well, it feels like we, humanity, are making that exact same trade-off right now.
I see where you're going with this.
Right. Like, we are simultaneously building these incredible tools capable of unlocking the deepest, most ancient secrets of the cosmos. But down here on Earth, we are sort of blinding ourselves.
Fracturing.
Yes, fracturing into these archaic, zero-sum conflicts over borders, trade, resources.
It's a really striking contradiction, if you look at the macro trends we're covering today.
Yeah.
From breakthroughs in artificial intelligence and quantum computing to the escalating kinetic warfare in the Middle East and Eastern Europe, we're a species that has never had more capacity to see the big picture.
But we just won't look at it.
Right. We seem increasingly determined to focus only on the immediate localized fight.
Well, let's test that theory for the learner listening today by starting with the widest possible lens. Let's look upward and backward.
I like that. Start big.
Because before we get to the immediate political crises, we really need to talk about some massive shifts in our understanding of how our own planet even came to exist.
The new planetary science data.
Exactly.
Wow.
Researchers at NASA, the National Aeronautics and Space Administration, have just completely overturned the prevailing theory on where the building blocks for life on Earth actually came from.
And this is a seismic shift in planetary science.
It really is.
For decades, the standard model held that early Earth was basically a dry, barren rock.
Right, just a hot ball of magma.
Exactly. The assumption was always that the volatile elements essential for biology, things like water, carbon, zinc, nitrogen, they had to be delivered much later.
Like a cosmic delivery service.
Yeah, exactly. We believe they came from the deep freeze of the outer solar system, brought in by this chaotic bombardment of icy comets and asteroids, acting as a sort of cosmic starter kit for life.
But the latest analysis of meteorite data says no. Earth actually shopped local.
We did.
We got what we needed from our own neighborhood. But how do we actually know that? Like, what are we looking at in these rocks that tells us their original zip code?
So we are looking at isotopic signatures.
Okay, break that down for me.
Sure. Elements come in different variations, or isotopes, depending on the number of neutrons in their nucleus. And the specific ratio of these isotopes acts like a chemical fingerprint.
Like a barcode.
Right, a barcode. The material that formed in the outer solar system has a very distinct isotopic ratio compared to the material that formed closer to the sun.
Because of the heat.
Exactly. The intense heat near the sun vaporized certain compounds. So by analyzing meteorites that crashed into Earth, the NASA researchers discovered that our planet's volatile elements overwhelmingly share the isotopic fingerprint of the inner solar system.
Okay, but if the outer solar system is just full of all this rich, icy, volatile material, why didn't it make its way to Earth?
In a word, Jupiter.
I knew it! The gas giant throws its weight around.
Literally. I mean, in the chaotic early days of planetary formation, Jupiter grew massively and very, very rapidly.
And how fast are we talking?
In cosmic terms, the blink of an eye. And it acted like an immense gravitational vacuum cleaner.
Wow.
It carved this massive trench in the protoplanetary disk, the swirling cloud of gas and dust around the young sun.
Right.
Jupiter's gravity basically either swept up the material from the outer solar system or violently ejected it out into deep space.
So it's a barrier.
It effectively created a gravitational blockade,
Yeah.
preventing that heavy, icy bombardment from reaching the inner planets.
So instead of a velvet rope bouncer keeping things out of a club, it's more like Jupiter dug a massive moat around the inner solar system.
That's a great way to look at it.
And Earth just had to coalesce from the rocky, seemingly drier debris that was already inside the moat.
Exactly. And this changes the fundamental math of astrobiology.
Because it means we don't need the comets.
Right. If we previously thought a planet needed a perfectly timed bombardment from deep space comets to become habitable, the odds of finding life out there seemed incredibly low.
It's too many variables.
Exactly. But if a rocky planet can gather the necessary ingredients locally, right from the inner disk where it forms, it means the universe might be far more fertile than we dared to imagine.
That's huge.
It means rocky exoplanets orbiting close to their stars might have the inherent capacity for life right from the start.
Which makes the hunt for those exoplanets a lot more exciting for everyone tracking this. And, speaking of the early chaos of our neighborhood, there's a new discovery out of the Sahara Desert in North Africa.
The new meteorite.
Yeah. Researchers found a meteorite that they believe is a piece of a lost moon-sized protoplanet from the very dawn of the solar system.
It's an incredible find.
But how do we know a rock in the sand is actually a ghost planet? I mean, a rock is a rock, right?
Well, it comes back to the chemistry and the cooling rate. This particular meteorite has a highly evolved crystallized structure.
What does that mean, crystallized?
It means it's not just a clump of primordial dust that bumped together. To get the specific crystalline structures observed in this rock, it had to have been part of a massive body that possessed a molten core and volcanic activity.
Like a real planet.
Exactly. And then it had to cool very, very slowly over millions of years. But its chemical composition doesn't match Mars, the Moon, Earth, or any known major asteroid like Vesta.
So it's an orphan.
It's an orphan, or more accurately, a casualty.
A casualty of what?
The early solar system was a violent billiard table. You had dozens of these moon-sized protoplanets just smashing into each other. Most were either swallowed by the sun or destroyed to form the planets we have today.
So this rock is...
This Sahara meteorite is essentially a single piece of shrapnel from a world that lost the evolutionary planetary war.
Man, it's humbling to think you can hold the remains of an entire destroyed world in the palm of your hand.
It really puts our existence into perspective.
It does. But we aren't just looking at the ghosts of our own system, right? We're starting to intercept visitors from others.
Yes, the James Webb Telescope data.
Exactly. The James Webb Space Telescope just focused its infrared sensors on an interstellar comet called 3I Telis.
Right, a rogue object.
Yeah, passing through our solar system from deep space. And they found a massive, unexpected abundance of methane surrounding it. Why does methane matter so much here?
Well, methane is a very simple organic molecule, one carbon atom bonded to 4 hydrogen atoms.
Okay.
In comets born in our own solar system, like the ones from the Oort cloud, methane is present, but usually in much smaller predictable ratios compared to other carbon compounds, like carbon monoxide.
But this one is different.
Completely different. The James Webb uses spectroscopy, which is basically analyzing the light passing through the comet's tail to see which specific wavelengths are absorbed by different gases.
Right, reading the chemical signature.
Yeah, and the data showed an overwhelming methane signature. This tells us that the protoplanetary disk where this comet formed, orbiting some completely unknown alien star, had a radically different thermal and chemical environment than our own.
So it's a sample.
Exactly. It's essentially a bottled sample of an alien solar system's atmosphere, delivered right to our doorstep.
It's just amazing that we can read the chemistry of a star system light years away just by looking at the ice boiling off a rock passing by.
It's brilliant engineering.
It is. But while we're analyzing distant stars, our own star is throwing a bit of a tantrum.
Yeah, the solar activity has been intense.
The sun has erupted with 3 massive solar flares back to back. And the reporting says we are getting hit by a Cannibal CME, a coronal mass ejection born from an anti-hale sunspot.
It's quite the combination of terms.
I really need you to break this down because Cannibal CME sounds like a sci-fi disaster movie. Are we just getting better at looking at the sun, or is the sun actually getting angrier?
It certainly sounds dramatic, but the physics are deeply fascinating. And no, it's not just us looking closer. The sun operates on an 11-year cycle of magnetic activity, and we are currently at solar maximum.
Okay, peak activity.
Right. And you have to remember, the sun isn't a solid sphere. It's a massive ball of superheated plasma. Because the equator rotates faster than the poles, the sun's magnetic field lines get stretched, twisted, and incredibly tangled over that 11-year period.
Like winding a rubber band too tightly until it snaps.
Precisely. And when those magnetic field lines snap and realign, a process called magnetic reconnection, they release a colossal amount of energy.
That's the flare.
That's a solar flare, a burst of intense radiation. Now, a coronal mass ejection, or CME, is when billions of tons of that superheated radioactive plasma are physically hurled out into space.
Okay, but what makes it a cannibal?
A cannibal CME happens when the sun fires off a relatively slow-moving plasma cloud, and then shortly after, from the exact same active region, it fires off a much faster one.
Oh, I see.
The fast wave literally catches up to the slow wave, sweeps it up, and consumes it.
Hence the cannibal name.
Right. Their magnetic fields merge, creating a massive, highly complex, and incredibly dense shockwave heading toward Earth.
Okay, that makes sense. And what about the anti-hale sunspot part? What makes a sunspot backwards?
So the Hale cycle dictates the magnetic polarity of sunspots. During a specific solar cycle, all sunspots in the northern hemisphere of the sun should have the same magnetic orientation.
Like all facing north.
Basically, say positive on the right, negative on the left, and the southern hemisphere will be the exact opposite. An anti-Hale sunspot violates this rule entirely.
It's backwards.
It is magnetically flipped relative to its surroundings. Imagine dropping a magnet with reverse poles into a tightly packed box of other magnets.
Oh, that would just push everything away, create chaos.
Exactly. The magnetic friction and instability it causes are immense. That's why this specific sunspot was violent enough to launch a cannibal CME.
Okay, so a massive, highly complex magnetic shock wave hits Earth. What actually happens down here? The reports say we get intense northern lights visible as far south as 23 U.S. states.
Which is beautiful.
It is. But it's not just a light show, right? Like, this actually messes with our tech.
Far from just a light show. When that magnetized plasma hits the Earth's own magnetic field, it causes a severe geomagnetic storm. The energy funneling into our atmosphere creates the auroras, but it also physically heats the upper atmosphere.
And heat causes expansion.
Exactly. That expansion creates sudden, intense atmospheric drag on low Earth orbit satellites. If they aren't actively maneuvered, they could literally fall out of the sky.
Wow.
Furthermore, the shifting magnetic fields induce massive direct electrical currents in long conductors on the ground.
You mean power lines?
Our power grids, yes. If transformers aren't protected, they can blow out entirely. We're also looking at the degradation of high-frequency radio communications, which impacts transoceanic flights.
Right, because they rely on radio over the oceans.
And disruptions to GPS timing signals, which coordinate everything from banking transactions to cellular networks. The vulnerability is huge.
And we have actual human beings floating around in that environment right now. Which brings us to a stark reminder from the International Space Station, the ISS.
The leak?
Yeah. The astronauts there had to temporarily abandon their normal operations and move into a docked SpaceX Dragon capsule, basically using it as a safe haven because an air leak in one of the Russian modules suddenly worsened.
It really shatters the illusion that space travel has become routine.
Right, we get so used to them just floating around doing science experiments.
The ISS is an engineering marvel, truly, but it is fundamentally aging infrastructure operating in the most hostile environment imaginable. It has been continuously occupied for over 2 decades.
That's a lot of wear and tear.
Tremendous wear. You have constant thermal stress baking in the sun, then freezing in the Earth's shadow 16 times a day. You have metal fatigue, micrometeoroid impacts, and the slow degradation of rubber seals.
So an air leak is almost inevitable.
Having to retreat to the lifeboats is a sobering reality check. The margin for error up there is functionally zero.
It's the ultimate hostile environment, and sometimes the environment simply wins.
Yes, like with Maven.
Right. NASA just officially decommissioned the Maven orbiter. That stands for Mars Atmosphere and Volatile Evolution. It suffered a fatal power failure in December 2025.
It had a fantastic run, though.
13 years. Orbiting Mars, producing hundreds of scientific papers. What did Maven actually teach us?
Maven's legacy is profound. Its entire mission was forensic. It was essentially sent to solve the mystery of how Mars died.
Because it used to be like Earth, right?
We know from geological evidence that billions of years ago, Mars had a thick atmosphere, riverbeds, liquid water on its surface. Today, it's an irradiated, freezing desert. Maven proved exactly how that happened.
How did it happen?
Mars, being smaller than Earth, saw its molten core cooled much faster. When the core solidified, Mars lost its global magnetic field.
This same shield we were just talking about that protects us from CMEs.
Exactly.
Yeah.
Without that magnetic shield, the solar wind, the exact same streams of charged particles from the sun began to literally strip the Martian atmosphere away, molecule by molecule, over eons.
Just blew it away into space.
Maven measured that atmospheric escape in real time.
Yeah.
It showed us the absolute mechanics of planetary death.
That is incredibly bleak. But, while our scientific probes reach the end of their lives, the commercial space sector is just relentlessly accelerating.
The pace is unbelievable.
SpaceX just launched back-to-back Falcon 9 Starlink missions from launch pads in California and Florida, separated by just 19 hours. The logistics of that are mind-bending.
It's a massive achievement.
Yeah, there's a fascinating bit of financial news attached to this. Wall Street is going crazy for space stocks, but the S&P 500, the premier benchmark index for the U.S. stock market, refused to bend its rules to allow SpaceX early entry.
Bureaucracy always wins.
It's just wild to me. You have a company literally catching rocket boosters out of the sky with mechanical chopsticks, aiming to colonize Mars, and they still have to wait in line for a bureaucratic committee to approve their paperwork.
It is the perfect collision of frontier engineering and legacy governance.
Right.
The S&P 500 Index Committee requires strict criteria, a history of consistent GAAP profitability, high public float, specific reporting standards.
Things a rapid growth tech company might not prioritize.
Exactly. SpaceX operates with the philosophy of moving at orbital velocity, iterating rapidly, and reingesting everything. They don't conform to the traditional quarterly earnings mindset of terrestrial corporate finance.
But the S&P is all about stability.
It is the bedrock of global passive investing. It demands stability over hype. However, the sheer operational Tempo 2 orbital launches in 19 hours from opposite coasts proves that access to space is no longer a bespoke scientific endeavor.
It's an industry.
It is an industrialized logistics operation. And eventually, the financial indices will have to adapt to the reality that the orbital economy is here.
Well, as we look at the extreme environments of space, we really have to recognize that Earth's own systems are equally dramatic, deeply interconnected, and right now under immense stress.
Oh, absolutely.
Let's shift our focus to the micro level, how life on Earth has adapted to extremes in the past, and what it means for our present climate crisis.
Okay.
In the Pyrenees Mountains, right on the border of Spain and France, archaeologists found a 5,500-year-old high-altitude mining site. They uncovered a child's tooth and these strange green stones. I'm just trying to picture being a Neolithic human dragging yourself up a freezing mountain to dig for rocks.
It speaks volumes about human drive and the early complexities of economics.
Because it wasn't just survival.
No, this wasn't just a shelter. It was an industrial operation in a brutal environment.
Yeah.
The thin air at that altitude causes hypoxia, the cold is relentless, and the caloric requirements just to survive are massive.
And yet they are up there mining.
Mining veracite, yes.
Yeah.
A green mineral used for high-status ornaments and trade.
So it's for jewelry.
Basically wealth and status. It tells us that even 5,500 years ago, human societies possessed the complex social organization, the division of labor, and the economic incentive to push themselves into extreme physiological danger simply to extract value from the earth.
We haven't changed much, have we?
Not fundamentally, no.
And it's not just humans who learn to survive the cold. In Italy, researchers pulled off something that sounds like Jurassic Park, but for the culinary world.
The Ötzi yeast. This is amazing.
Yeah. They successfully extracted ancient cold-resistant yeast from the gut of Betsy the Iceman, the famous 5,300-year-old mummy found frozen in the Alps. And then they cultured it and used it to bake a loaf of bread.
It is a stunning intersection of microbiology and archaeology.
But how does yeast survive in a frozen mummy for 5 millennia?
Because Ötzi was rapidly frozen in a glacier, the microbiome in his digestive tract was essentially cryopreserved. Yeast, as an organism, is remarkably resilient.
Like it just goes to sleep.
Exactly. When faced with freezing temperatures or starvation, it can form spores and enter a state of suspended animation, just waiting for the environment to improve.
So they just woke it up.
By reviving this specific 5,300-year-old strain, scientists aren't just creating a prehistoric sourdough starter, although that is fun.
I mean, I would try it.
They are unlocking the evolutionary history of industrial microorganisms. They can sequence its genome to understand the specific metabolic pathways it used to survive extreme cold.
And use that today.
Exactly. That knowledge can be directly applied today in industrial fermentation, pharmaceuticals, and creating hardier crops. We are literally studying the ancient past to engineer the future.
It's amazing that an entire ancient ecosystem was preserved in ice. But we also have massive hidden natural systems keeping things alive right now. Geologists just finished mapping a completely secret underground cave system in the Grand Canyon in Arizona.
The scale of that mapping project is staggering.
It turns out that snowmelt from miles away flows through these deep subterranean channels to replenish the springs at the bottom of the canyon. How did we not know about an underground river in the Grand Canyon?
Well, this is a masterclass in karst hydrogeology.
Karst.
Yes. The Grand Canyon is dominated by limestone. Over millions of years, water, which is slightly acidic from absorbing carbon dioxide in the soil, seeps into the rock and slowly dissolves it.
Creating caves.
Right, creating an immense porous sponge of underground caves and aquifers. In a fundamentally arid environment like the American Southwest, the springs at the bottom of the canyon are critical oases.
They keep the animals and plants alive.
They sustain the entire localized ecosystem. But what this mapping project reveals is how dangerously interconnected the system is. The health of the canyon floor isn't dictated by rain falling into the canyon.
It's from the snow miles away.
It is entirely dependent on the snowpack accumulating on the Cannibal Plateau, which is miles away and thousands of feet higher. If climate change reduces that winter snowpack, the deep plumbing dries up and the oasis dies.
Which is the perfect entry point to talk about the intensifying climate crisis right now because the global plumbing is backing up.
It is severely stressed.
The World Meteorological Organization, the WMO, has issued an urgent warning of an 80 to 90% chance of a severe El Niño developing. And we're already seeing the physical proof.
The Kelvin wave.
Right. The Sentinel-6 Michael Freilich satellite, which tracks sea levels with incredible precision, observed a massive warm Kelvin wave moving across the Pacific Ocean. It literally raised sea levels by 15 centimeters off the coast of Peru. How does a wave of warm water physically raise the ocean level by half a foot?
It's pure thermodynamics, specifically thermal expansion.
Okay, lay it out for me.
Let's look at the mechanics of the El Niño Southern Oscillation, or ENSO. Under normal conditions, the trade winds blow strongly from east to west across the Pacific. They push all the sun-warmed surface water toward Asia, piling it up near Indonesia.
So the water is physically higher over there.
Exactly. But during an El Niño event, those trade winds weaken, or sometimes even reverse. When that pressure drops, all that trapped, warm surface water begins to slowly slosh back eastward toward South America.
Like water in a bathtub.
Exactly like that. That massive, deep pulse of heat moving beneath the ocean's surface is the Kelvin waves. And because warm water molecules vibrate faster and push further apart than cold water molecules, the water physically expands.
Oh, so it's not just more water. The water itself is taking up more space.
Precisely. The satellite is measuring that exact thermal expansion, a literal bulge in the ocean.
And climate scientist Paul Roundy was quoted in the reporting warning that this specific Kelvin wave could lead to the highest amplitude El Niño event in a century. He's predicting hotter summers, viciously colder winters, and massive disruptions to global food supplies.
Yes. When scientists talk about amplitude in this context, they mean the sheer volume of heat energy being released from the ocean into the atmosphere.
And the Pacific is huge.
The Pacific Ocean is the largest heat sink on Earth. When it vents that much thermal energy, it violently disrupts global atmospheric circulation, specifically altering the path of the jet streams.
So it changes where the rain goes.
This is why an El Niño is so disruptive. It acts as a global weather multiplier. It can cause devastating multi-year droughts in Australia, India, and Southeast Asia, leading to massive crop failure.
And the opposite elsewhere.
Right. Simultaneously, it funnels atmospheric rivers of moisture into the Americas, causing catastrophic flooding and landslides. And because this massive natural cycle is occurring on top of a baseline of human-induced global warming, the extremes are supercharged.
We are already seeing those supercharged extremes. Look at the reporting on Super Typhoon Senlaku. It was a Category 5 equivalent storm. It hit the Mariana Islands in the Pacific. But the detail that blew my mind is that it happened in April.
Which is incredibly early for a storm of that magnitude.
Right. And the storm was so intense that it generated atmospheric gravity waves that were clearly visible from space. I mean, imagine dropping a massive house-sized boulder into a perfectly still pond. You get those massive rippling rings pushing outward. That is essentially what this typhoon did, but the pond is our atmosphere, and the boulder is a column of rapidly rising, superheated air.
That is an incredibly accurate way to visualize it.
Well, thank you, but how does that happen?
The mechanism driving this is extreme convection and buoyancy. The heat from the ocean surface feeds the typhoon, forcing millions of tons of hot, moist air violently upward.
Just a massive updraft.
Right, when that massive updraft hits the tropopause, which is the boundary layer where the stratosphere begins and the air becomes very stable, it acts exactly like a boulder hitting the surface of a pond.
It has nowhere else to go but out.
Exactly. It displaces the stable stratospheric air, creating immense ripples or gravity waves that propagate outward for thousands of miles.
So it affects other places.
These waves transport huge amounts of momentum and energy across the globe, meaning a localized typhoon in the Pacific can actually alter the weather patterns over North America days later. It is visceral proof that in a fluid atmosphere, there is no such thing as a local storm.
And while that's happening, we have Tropical Storm Jangmi battering Japan, cutting power to 60,000 homes in Shizuoka and Tokyo. It feels like the global infrastructure is just constantly under siege from the sky.
It is. And this is where the meteorological reality crashes into the geopolitical reality.
How so?
Well, when a severe El Niño disrupts the Indian monsoon or causes widespread drought in the American Midwest, the immediate result is a plunge in agricultural yields.
Which means less food.
That creates food scarcity. Scarcity drives up commodity prices on the global market.
And people panic.
Historically, sudden spikes in food prices are the primary catalyst for civil unrest, mass migration, and political instability in developing nations. You cannot decouple the climate system from the human political system. They are part of the same risk matrix.
So, if the climate is becoming increasingly hostile and our legacy systems are failing, our survival inherently relies on innovation. We have to engineer our way out of this.
That's dope.
Which brings us to some massive technological leaps happening right now in quantum computing, AI, and biotechnology. Let's start with the hardware. Microsoft just announced a breakthrough with a new quantum chip that they claim is 1,000 times more reliable than its predecessor. That sounds like a massive jump. What exactly did they fix?
They cracked the code on error correction, which has been the holy grail of quantum mechanics for years.
Okay, so how does it work?
Well, traditional computers process information in bits, absolute states of 0 or 1. Quantum computers use qubits, which leverage a principle called superposition.
Meaning they can be both.
Yes, allowing them to exist as 0, 1, or any probability of both simultaneously. This allows them to calculate an almost unimaginable number of possibilities at once.
Sounds perfect. What's the problem?
The problem is that qubits are notoriously fragile. The slightest environmental interference, a stray photon, a microscopic fluctuation in temperature, even ambient electromagnetic noise, causes the qubit to lose its quantum state.
It just breaks.
It's called decoherence, and it introduces massive errors into the calculation.
So how did Microsoft fix it?
Microsoft's breakthrough involves using logical qubits built from multiple physical qubits, utilizing complex topological redundancy.
Meaning they back each other up?
Basically, yes. They've figured out how to make the system check and correct its own math in real time without collapsing the quantum state.
That's incredible.
Moving from a theoretical, highly unstable lab experiment to a reliable commercial architecture means we are finally approaching the era where quantum computers can simulate complex molecular interactions.
But for medicine?
Exactly. That is how we discover new pharmaceuticals or engineer next-generation carbon capture materials that traditional supercomputers would take millennia to model.
Speaking of next-generation materials, there's a study out that completely breaks my brain. Researchers have discovered a quantum effect using atomic vibrations that could allow small devices to convert ambient electrical signals directly into current.
The batteryless tech.
Yeah. The implication is that we could potentially eliminate the need for traditional batteries. But wait, if we are pulling ambient energy from radio waves to power devices, does that mean a room filled with these batteryless gadgets would create dead zones for cell service? Are we just cannibalizing one frequency to power another?
It's a brilliant question. But no, you won't lose your cell signal. It's not about draining the primary signal. It's about harvesting the noise.
The noise.
The technology is called ambient energy harvesting.
Yeah.
Our modern environment is bathed in stray electromagnetic energy radio frequencies,
Yeah.
Wi-Fi signals, even microscopic thermal fluctuations.
So it's energy floating around.
Right. The researchers engineered a nanoscale material with highly specific, deliberate imperfections in its atomic lattice.
Like what?
Imagine a microscopic trampoline. When the stray ambient waves hit this material, it forces the atoms to vibrate at a resonant frequency. Because of those intentional imperfections, the bouncing motion is funneled in a single direction.
And that creates power.
It knocks electrons loose and generates a tiny, steady stream of direct current.
Wow.
Now, it won't power an electric vehicle or a smartphone, but for low-power Internet of Things devices, like structural sensors embedded permanently inside a concrete bridge or a pacemaker inside a human chest, it means the device can operate indefinitely, continuously pulling power from the ambient environment without ever needing a battery replacement.
That is profound. But while the hardware is taking huge leaps, the software, specifically artificial intelligence, is experiencing an absolute explosion. Look at Anthropic, the AI safety startup.
Their numbers are staggering.
Their annualized revenue jumped from $9 billion in late 2025 to over $47 billion by May 2026 as they prepare for an IPO. That isn't just growth, that is a fundamental reordering of the global economy.
It proves that large language models, or LLMs, have transitioned from novel consumer chatbots into foundational enterprise infrastructure. Every major corporation on Earth is integrating these models into their core operations.
But the most critical piece of news in the AI sector today isn't Anthropic's revenue. It's the reporting that the NSA, the National Security Agency, is actively readying Anthropic's Claude Mythos model for cyber operations.
This is a huge development.
That feels incredibly significant, taking a commercial AI and handing it to the NSA for offensive operations.
It is the crossing of the Rubicon for the militarization of AI.
Why is it so dangerous?
LLMs are the ultimate dual-use technology. If an AI model is sophisticated enough to analyze millions of lines of proprietary corporate code to help a developer find a bug, that exact same neural network architecture can be directed to analyze an adversary's network traffic.
And find a way in.
Exactly. Reverse engineer their encryption protocols and hunt for zero-day vulnerability.
It's a weapon.
The intelligence community adopting commercial AI models for cyber operations signifies that the digital arms race is no longer theoretical. AI agents are being deployed as active combatants in the invisible cyber war.
And they're being deployed as agents in the corporate world, too. OpenAI just launched new codex tools aimed strictly at white-collar automation. And Microsoft unveiled Scout, an AI assistant for Microsoft 365.
Project Solara.
Right. They are pushing something called Project Solara, which fundamentally shifts how computers work. Instead of opening apps, the device operates via AI agents.
This is a massive paradigm shift in human-computer interaction.
How so?
Well, for 40 years, the software model has been tool-based. You open a spreadsheet, you input the data, you apply the formula, you do the reasoning.
Right, the human is driving.
Exactly. Project Solara moves us to an agent-based model. You don't open applications anymore. You speak to an OS-level AI agent and give it an intent.
Like what?
You say, gather last quarter's sales data across all regions, identify the weakest performing products, draft a memo to the regional managers explaining the shortfall, and schedule a meeting for Tuesday.
And it just does it.
The AI agent autonomously makes the API calls, navigates the databases, performs the analytical reasoning, drafts the text, and interacts with the calendar software.
That's wild.
It replaces not just the tool, but the human workflow required to use the tool.
Which explains why global regulators are completely freaking out and completely divided on how to handle it. We saw Europe's VivaTech conference heavily feature the new EU Artificial Intelligence Act.
The EU is taking a very different path.
Yeah, the EU is pushing for stringent ethical governance and a shift toward what they call neurosymbolic AI. They are actively fighting back against the Silicon Valley ethos of move fast and break things.
Yes.
Meanwhile, over in the United States, President Donald Trump just signed a new executive order on AI that essentially guts mandatory testing. Bowing to massive industry pressure, the new EO only requires voluntary pre-release reviews.
What we are watching is a deep structural clash of political philosophies regarding existential technology.
Break down the EU side first.
The European Union is operating strictly on the precautionary principle. The EU AI Act attempts to categorize AI models by risk, placing heavy regulatory burdens, transparency requirements, and human rights audits on anything deemed high risk.
And what is neurosymbolic AI?
Their push for neurosymbolic AI is fascinating. Current LLMs are deep learning neural networks. They are massive black boxes.
We don't know how they think.
Even the engineers who build them can't explain exactly how the model arrived at a specific conclusion, Neurosymbolic AI attempts to fuse the pattern recognition of deep learning with the strict, transparent, rule-based logic of traditional programming.
So it forces it to explain itself.
Exactly, forcing the AI to show its work and making its reasoning auditable.
But critics of the EU approach say that all this regulation just ensures Europe will lose the tech race, and that seems to be the exact philosophy behind the U.S. approach under the Trump administration.
Exactly. The American approach, codified in the new executive order, is rooted in strategic accelerationism.
Which means?
The argument from the administration and industry leaders is that heavy-handed regulation will simply strangle innovation, driving the brightest minds and the capital to less regulated jurisdictions.
So they just let it rip.
By making safety reviews voluntary, the policy accepts the risk of domestic market disruption and potential algorithmic harm in exchange for maintaining global dominance.
It's all about China, isn't it?
The calculation is stark. If the U.S. pauses to regulate, geopolitical rivals like China, who view AI dominance as a core national security imperative, will surge ahead. It's the classic innovator's dilemma on a geopolitical scale. Prioritize public safety or secure strategic supremacy.
It's an incredibly high-stakes gamble. And frankly, the technological leaps aren't just happening in silicon, they're happening in our own biology. Let's look at the medical breakthroughs, because our understanding of human intelligence and disease is shifting just as fast as AI.
The microbiome research is revolutionary right now.
It really is. Researchers have just published a major study linking specific combinations of gut bacteria to early indicators of autism and ADHD in 3-year-olds. We've talked about the gut microbiome before, but how can bacteria in your stomach dictate neural development in your brain?
It fundamentally rewrites our understanding of neurology through the gut-brain axis.
Gut-brain axis.
For a long time, medical science viewed the brain as an isolated, privileged fortress protected by the blood-brain barrier.
Nothing gets in.
Right. But the human digestive tract contains trillions of microorganisms, the microbiome. And these bacteria aren't just passive passengers digesting food. They're incredibly active biochemical factories.
What are they making?
They produce massive quantities of neurotransmitters, including serotonin and dopamine, as well as short-chain fatty acids.
Wait, my stomach makes dopamine.
A huge percentage of it, yes. These neuroactive chemicals communicate directly with the central nervous system via the vagus nerve, which runs straight from the gut to the brain. If this study is correct, and specific bacterial profiles can act as highly accurate biomarkers for neurodevelopmental conditions like autism and ADHD, it suggests that these conditions are systemic, not just localized in the brain.
And we could treat it early.
More importantly, it opens a revolutionary window for early intervention. If you can identify the risk at age 3, you could potentially alter the trajectory of neural development through targeted probiotics, dietary interventions, or microbiome therapies during the brain's most critical period of neuroplasticity.
That is the best possible use of biology. But unfortunately, biology is incredibly stubborn, and sometimes the body actively fights our best efforts to cure it.
Which is incredibly frustrating for oncologists.
Yeah, there is another study out detailing how a specific protein called NFIL3 is causing what they call T-cell exhaustion, and it's holding back CAR T-cell therapy for cancer. Let's break this down. What is a CAR T-cell, and how does a cell get exhausted?
CAR T-cell therapy is arguably the most potent weapon we have ever developed against cancer. It is a living drug.
How do they make it?
Doctors extract a patient's own immune system T-cells, use a lentiviral vector to genetically engineer them in a lab, so they grow special receptors called chimeric antigen receptors, or CARs.
Okay, what do the CARs do?
These receptors are perfectly tuned to seek out and bind to the specific proteins on the surface of the patient's cancer cells. The modified T-cells are then multiplied into the millions and infused back into the patient, essentially creating a personalized army of microscopic assassins.
But they get tired.
They do, particularly in solid tumors like lung or breast cancer. Solid tumors are diabolical. They create a highly immunosuppressive microenvironment around themselves,
Like a shield.
essentially deploying chemical smoke screens and physical barriers. When the engineered CAR T-cells enter this environment, they engage the tumor and fight relentlessly. But the constant, overwhelming antigen exposure triggers a biological failsafe known as exhaustion.
The cell just gives up?
The T-cells lose their ability to replicate, their toxic payload diminishes, and they eventually undergo programmed cell death.
So what's the breakthrough with the NFIL3 protein?
What researchers discovered is that the NFIL3 protein acts as the master switch for this exhaustion pathway. It alters the gene transcription within the T-cell, telling it to shut down.
So if we turn off the switch...
The breakthrough here is immense.
Yeah.
If geneticists can use CRISPR to knock out or suppress the NFIL3 gene before they infuse the cells back into the patient, they could create T cells that literally never get tired. They could engineer a relentless immune response that destroys the solid tumor completely.
It is molecular warfare on the grandest scale, which brings me right back to my favorite piece of biology today, the deer kicked.
Ah, yes. The insect.
Lepoptina cervi. I just cannot get over the fact that an animal would purposefully destroy its own ability to see. It's wild.
It's all about metabolic economics.
Yeah.
Neural tissue, specifically the brain structures and optic nerves required to process high-resolution visual data in real time, is incredibly expensive to maintain.
It burns calories.
It burns a massive amount of calories. For a flying insect actively searching through a forest for a host, vision is an absolute necessity.
Right.
But the moment the keyed lands on a deer, burrows into its fur, and begins feeding on its blood, it has transitioned from a free-roaming navigator into a permanent, stationary parasite.
So it doesn't need to see.
At that point, the high-resolution vision isn't just useless, it is a metabolic liability. Evolution is utterly ruthless regarding efficiency.
Use it or lose it.
By physically shedding its wings and down-regulating the genetic transcription for vision, the key reallocates all of that massive energy expenditure straight into reproduction and blood consumption.
See, I find this deeply unsettling.
Why is that?
Because it feels like a perfect, terrifying analogy for human technological reliance. We are building these AI agents with Project Solara to do our writing, our data analysis, our scheduling. We are offloading our cognitive load.
We are outsourcing our thinking.
Exactly. It makes you wonder, if the AI is doing all the heavy lifting for our critical reasoning, do our own cognitive muscles start to atrophy? Are we shedding our intellectual wings? Are we, as a species, uninstalling our own capacity to see the big picture because we found a comfortable host in our technology?
It's a sobering analogy, and neuroscientists would argue it's not entirely theoretical.
Really?
Neuroplasticity dictates that the human brain strengthens the synaptic pathways it uses regularly and ruthlessly prunes the ones it doesn't. If we systematically outsource complex analytical reasoning, spatial navigation, and long-form comprehension to external AI systems,
The brain adapts.
the corresponding neural architecture in our brains will inevitably adapt to that reduced workload. We could very well be engineering our own cognitive reduction.
Well, looking at the state of the world right now, it feels like our critical reasoning is already failing us.
It's a messy geopolitical board.
It really is. Let's move into the final part of our deep dive, the geopolitical game board. Because while scientists are mapping the complexities of the gut microbiome and quantum error correction, global leaders are dragging us back into incredibly archaic brute force conflicts.
The contrast is stark.
Let's look at the rapidly escalating situation in the Middle East. And as a reminder to the learner, we are relying on international reporting to analyze the raw data of these events, focusing on the strategic implications rather than taking a political side.
Right, impartial analysis.
The U.S.-Iran flashpoint is terrifying right now.
Yeah.
Israel recently struck a hospital in southern Lebanon, resulting in 11 deaths. And the reporting notes this happened right after a U.S. brokered truce was rejected by Hezbollah.
This is the collapse of the deterrence framework in the Levant.
How so?
The United States and international diplomats were frantically attempting to establish a localized ceasefire, hoping to decouple the daily artillery exchanges on the Lebanese border from the broader regional conflict.
But it failed.
However, Hezbollah's leadership rejected the truce, calculating that maintaining kinetic pressure on Israel provides them with essential strategic leverage.
And the hospital strike.
The resulting Israeli airstrike on a hospital complex highlights the brutal reality of asymmetric warfare. When militant infrastructure is deeply embedded within civilian populations, the collateral damage is catastrophic, drawing immense international condemnation and making future diplomatic off-ramps virtually impossible to navigate.
And the conflict isn't contained, it is spilling directly into the Gulf. The U.S. military fired missiles at an Iranian drone and radar site near the Strait of Hormuz.
Yes.
And Iran didn't back down, they retaliated. They struck a U.S. military vessel, hit a command center in the Sea of Oman, and targeted U.S. bases located in the sovereign nations of Kuwait and Bahrain. One person was killed and dozens were injured at the Kuwait airport.
This is the nightmare scenario that global defense planners have been modeling for decades.
A direct war.
A direct, state-on-state kinetic exchange between the United States and Iran. The Strait of Hormuz is the central artery of global energy. Roughly 20% of the world's total oil consumption passes through that narrow waterway.
So it's a choke point.
The initial U.S. strikes were designed to degrade Iran's capability to harass commercial shipping and launch surveillance drones. But Iran's retaliation crosses a massive red line.
By hitting other countries.
By striking U.S. assets directly, and, more importantly, by launching munitions into the sovereign territory of U.S. allies like Kuwait and Bahrain, Iran is demonstrating an incredibly high-risk tolerance. They are signaling that they are willing to climb the escalation ladder.
What does this mean for the idea of a clean war?
For years, military strategists have talked about the illusion of chasing the perfect war, the idea that a superpower can use precision-guided munitions to eliminate threats with surgical precision and minimal cost.
But that's not happening here.
This exchange proves that as a fallacy. Once you launch a missile, the adversary gets a vote, and the economic shockwaves are immediate. Global shipping insurance premiums skyrocket, oil futures spike, and global supply chains brace for impact.
Speaking of supply chains bracing for impact from warfare, look at the spillover in Eastern Europe. A Ukrainian sea drone literally exploded in Constanta, Romania.
That was a highly alarming incident.
The reporting says it veered violently off course due to electronic interference.
This perfectly illustrates the unique dangers of modern, highly automated warfare. The Black Sea is currently the most intense electronic warfare, or EW, environment on the planet.
What does that actually look like?
Both Russian and Ukrainian forces are constantly jamming GPS signals, spooking radar, and severing command and control links to drones.
So the drone just gets lost.
When a loitering munition or an explosive sea drone loses its navigation link, it doesn't just disappear, it becomes a blind floating torpedo.
And it hit Romania.
Constanta is a major port city in Romania. Romania is a NATO member. This means an active munition from the Ukraine conflict just detonated inside NATO territory.
Could that start a wider war?
It was an accident caused by signal jamming, but it highlights how a single technical glitch in a chaotic EW environment could inadvertently trigger Article 5 mutual defense clauses, dragging the entire NATO alliance into direct conflict.
And domestically, the situation for Ukraine is dire regarding manpower. The U.S. House just passed a major bill supporting Ukraine with hardware, but Ukraine is actively pressuring the European Union to return military-aged male refugees to fight.
It reveals the brutal arithmetic of a war of attrition.
Because machines need people.
Exactly. The West can provide billions of dollars in artillery, air defense, and F-16s, but military hardware is useless without trained operators. Ukraine has suffered horrific casualties, and their diplomatic push to have European nations repatriate refugees places the EU in an excruciating position.
It's a huge conflict of interest.
It pits the fundamental human rights and asylum protocols of the European Union directly against the existential survival needs of a besieged ally.
It's a moral and logistical nightmare. And the political shakeups back in the U.S. aren't adding any stability. President Trump has just appointed 38-year-old Bill Pulte as the acting director of national intelligence, the DNI, replacing Tulsi Gabbard.
A very controversial appointment.
The reporting explicitly notes that Pulte, who was the director of the Federal Housing Finance Agency, lacks any intelligence background, but is viewed as a staunch political loyalist. Critics argue this lacks the necessary expertise, but supporters say it brings an outsider's operational loyalty to a deeply bureaucratic system. How does this appointment actually change the mechanics of global intelligence?
Well, the Director of National Intelligence is arguably the most sensitive bureaucratic position in the federal government. The DNI is responsible for synthesizing the raw data, signals intelligence, and human espionage from all 18 distinct U.S. intelligence agencies, including the CIA and the NSA.
And they brief the president.
Right, delivering the daily, highly classified intelligence brief. The traditional view is that this role requires decades of deep subject matter expertise in geopolitics, statecraft, and covert operations to properly filter the noise from the signal.
So putting a housing finance guy in there changes things.
Appointing someone from the housing finance sector fundamentally changes the dynamic. It represents a governing philosophy that prioritizes absolute ideological alignment with the executive branch over institutional experience.
What's the risk there?
The inherent risk, as flagged by intelligence veterans in the reporting, is the politicization of intelligence. The intelligence community's job is to deliver objective, often deeply uncomfortable truths.
Things the president might not want to hear.
Exactly. If the DNI acts as a political filter rather than an objective analyst, the executive branch risks making decisions based on what it wants to hear, rather than the reality on the ground, which is incredibly dangerous during a volatile period like the U.S.-Iran exchange we just discussed.
And the administration is also using maximum leverage on the economic front. Trump has formally proposed a blanket 10% tariff on 60 different nations, citing forced labor probes.
It's a massive shift in trade policy.
And this isn't just targeting adversaries. The list includes core allies like Canada, Mexico, the UK, and the European Union. How does placing a 10% tax on your closest trading partners not just blow up the global supply chain? Are we seeing the death of globalization and the rise of walled-off economic fortresses?
We are absolutely witnessing the weaponization of international trade. And it's vital to understand the mechanism of a tariff.
Who actually pays for it?
A tariff is not paid by the exporting country. It is a tax paid by the domestic importing company, which invariably passes that cost directly onto the consumer, fueling inflation.
So prices just go up?
Yes. Using forced labor probes provides a legal and moral justification under international trade law, but applying a blunt 10% tariff to 60 nations simultaneously, especially deeply integrated partners like Canada and Mexico, who are part of the USMCA trade agreement, is a massive shock to the global economic system.
How do companies adapt to that?
It forces multinational corporations to completely abandon the philosophy of just-in-time global logistics. They can no longer rely on a frictionless, optimized global market.
So they have to move their factories?
Instead, they are forced into nearshoring or friendshoring, spending billions of dollars to aggressively relocate their manufacturing and supply chains to countries deemed politically safe. It inherently creates walled economic fortresses, sacrificing global efficiency for national security and political leverage.
Which opens the door for other nations to completely game the system. Look at India. The intelligence briefings highlight how India is leveraging the U.S.-China rivalry through a strategy of multi-alignment and capitalizing on the China plus one corporate movement.
India's current foreign policy is a masterclass in ruthless geopolitical pragmatism.
What is multi-alignment?
Multi-alignment is a rejection of the Cold War mentality of choosing a single bloc. India maintains deep strategic and military partnerships with the West, participating in the Quad security dialogues with the U.S., Japan, and Australia.
But they also deal with Russia.
Simultaneously buying massive quantities of discounted Russian oil in defiance of Western sanctions, and maintaining robust trade with the Gulf states.
And the China plus one thing.
The China plus one strategy is their economic engine. Because Western corporations are terrified of tariffs and the political risk of manufacturing exclusively in China, they want a backup plan. The plus one.
And India is raising its hand.
India has aggressively positioned its massive labor force and emerging infrastructure to be that primary alternative, capturing billions in foreign direct investment to build its domestic manufacturing base while refusing to compromise its sovereign independence.
But smaller nations don't have that kind of leverage, do they? Look at Armenia. The reporting shows Armenia is aggressively pivoting away from Russia and trying to align with the European Union.
It's a very dangerous pivot.
Because the cost is brutal. Economists project a 14% drop in their GDP if they lose the benefits of the Russian-led Eurasian Economic Union, the EAU.
It perfectly illustrates the brutal mathematics of sovereignty. For decades, Armenia has been deeply tethered to Russia for security guarantees and economic integration.
Why leave now?
Following recent regional conflicts where Armenia felt Moscow abandoned them, Prime Minister Pashinyan is making a desperate, historic pivot toward Western democratic alignment.
But untangling from Russia is hard.
Incredibly painful.
Yeah.
A 14% contraction in GDP isn't a recession. It is a full-blown economic depression. It means massive unemployment and the collapse of domestic industries tied to Russian markets.
The cost of independence.
It highlights the agonizing calculus smaller nations face in a multipolar world. The pursuit of political independence almost always exacts an immediate, devastating economic toll.
It's all connected. The economy, the politics, the climate. Let's finish by looking at how all of these tensions are bubbling up on a completely different stage. International sports.
The World Cup.
The 2026 World Cup is rapidly approaching, hosted jointly by the U.S., Canada, and Mexico. It is a massive undertaking with 48 teams and 104 matches. But it's already mired in controversy that reflects the broader global issues we've discussed.
It really does.
A viral video out of the Senegal camp shows incredibly dangerous, uneven turf conditions in the American stadiums. And then you have FIFA banning reusable water bottles for fans, despite severe heat warnings across North America.
Sports at this scale are never just sports. They are multi-billion-dollar logistical empires that act as a mirror for society.
How does the turf fit into that?
The turf issue is a perfect example of infrastructure friction. These massive American stadiums were built for the biomechanics of American football, not the highly specific, highly regulated roll and bounce requirements of international soccer. Trying to retrofit one standard onto another is causing physical danger to the athletes.
Water bottles.
The water bottle ban is particularly egregious, especially given the climate data we discussed earlier regarding the severe El Niño.
Right, it's going to be boiling hot.
With the WMO predicting record-shattering summer temperatures, prioritizing corporate sponsorship exclusivity forcing fans to discard reusable bottles and purchase officially branded water inside the stadium over basic public health during a heat wave is a stark demonstration of how commercial imperatives frequently override human safety in mega events.
And the jersey itself is becoming a political weapon. In Colombia, the national yellow jersey has morphed from a symbol of unity into a deeply divisive political statement amid massive social turmoil.
Historically, the national team jersey is the one sacred object that transcends domestic political divides. Everyone bleeds the same colors.
But not anymore.
But in Colombia, amidst profound economic inequality and social protests, that unifying symbol has been completely co-opted. Depending on the context and the crowd, wearing the yellow jersey can signify staunch support for the government and the status quo, or it can be worn by thousands of protesters in the streets as a demand to reclaim the national identity from the elite class.
So it's completely polarized.
The jersey has become a proxy battleground for the nation's soul. It proves that the geopolitical game board isn't just played in situation rooms or via quantum algorithms or through international tariffs. It's played out in the stadiums and on the streets by everyday people.
It really is a mirror for everything we've talked about today. Let's try to synthesize this incredible journey for the learner listening.
We covered a lot of ground.
We started at the literal birth of our planet, learning how Jupiter acted as a gravitational vacuum, clearing the way so early Earth could gather its essential elements locally. We explored the explosive mechanics of Cannibal CMEs and anti-hale sunspots threatening our modern grids, and we marveled at human resilience, from 5,500-year-old high-altitude mining to 5,300-year-old cryopreserved yeast.
And mapped the underground of the Grand Canyon.
Yes, the hidden karst aquifers of the Grand Canyon, and tracked the thermal expansion of a massive El Niño pushing global extreme weather to the brink. We unpacked the mind-bending reality of quantum error correction and batteryless ambient energy harvesting. We watched the NSA militarize AI, and researchers discovered the genetic exhaustion switch in cancer-fighting T cells.
All while mapping the geopolitical fracturing.
Exactly. Navigating a brutally fractured geopolitical landscape, from direct kinetic strikes between the U.S. and Iran in the Gulf, to the weaponization of tariffs, the brutal economics of Armenian sovereignty, and the political co-opting of the World Cup.
It is a vast, incredibly complex tapestry of human endeavor, resilience, and conflict. Which brings me right back to the biological anomaly we started with.
The deer cat.
Yes. We talked about the deer cat, an insect that willingly sacrifices its vision, literally downregulating the genes that allow it to see the moment it finds a comfortable host. It trades its ability to perceive the wider world for the immediate, effortless gratification of sustenance and survival.
And the parallel is striking.
Look at humanity today. We possess truly visionary technology. We have quantum computers that can model reality at the atomic level. We have satellites that can measure a 15-centimeter thermal bulge in the Pacific Ocean from orbit. We have artificial intelligence models that can decode the epigenetic pathways of our own biology.
But our behavior doesn't match our vision.
Yet when we look at our geopolitical structures, our trade policies, and our kinetic conflicts, we are largely operating on archaic, short-term, zero-sum survival tactics. We throw punitive tariffs, we launch territorial strikes, and we hoard resources.
So what's the takeaway?
The question for you, the learner, to explore as you go about your week is this. As a species, will our political and social evolution ever catch up to our technological vision? Or will we, like the deer cat, ultimately shed our ability to see the bigger picture just to consume what is immediately in front of us?
A heavy, deeply necessary question to mull over. Thank you for joining us on this deep dive. Keep looking up, keep looking closely, and most importantly, keep questioning the world around you.
You're enjoying Artificially Informed.
Hit subscribe and share it with a friend.
From the left, the right, and straight from the algorithm.
Thank you.
Welcome to the debate. Right now, the world's most vital shipping lanes are choked off by military conflict.
Yeah, and a massive land war is just grinding on in Eastern Europe.
Exactly. Plus, the United States is proposing these sweeping, unprecedented tariffs that are frankly actively alienating its global allies.
Which is wild to watch.
Right. So, by all traditional metrics, The global economy should be in a catastrophic synchronized recession right now. But why isn't it?
Well, I mean, that is exactly the illusion I want to dismantle today. Because underneath all that surface-level market data, the structural damage is profound.
And that is the crux of our discourse today. Are these simultaneous geopolitical and economic crises driving the planetary economy into a period of prolonged, destructive fragmentation, or...
Or, as you usually argue, are they necessary growing pains?
Right, exactly. The growing pains forging a more resilient multipolar world order. I will argue that this global friction, from shifting supply chains to these sweeping tariff realignments, represents a necessary structural correction. We are finally moving away from a fragile, hyper-centralized global system toward a balanced multipolar resilience.
And I will argue that what you are calling growing pains is actually the systematic destruction of established diplomatic and economic norms. We are witnessing reckless economic warfare, plain and simple. This isn't some neat transition to resilience. It is a chaotic fragmentation that risks devastating global hunger, deep market collapse, and unchecked regional conflicts.
Well, let me frame my position by looking at the actual mechanics of what is happening. For the last 40 years, we built a planetary economy based entirely on just-in-time efficiency.
Right, extreme cost-cutting.
Exactly. It was a marvel of cost-cutting. But it was incredibly brittle. I mean, we ignored ethical violations like forced labor, we ignored massive state-sponsored industrial overcapacity, and we completely ignored the glaring dangers of single-point supply chains.
Like relying entirely on one country for manufacturing?
Yes, or one straight for global energy. What we are seeing today is the violent transition to a just-in-case economy. I posit that policies like the proposed U.S. tariffs and the strategic realignment of nations like India are proof that the global economy is adjusting.
India balancing the US, China, and Russia, you mean?
Right. They are brilliantly balancing those relations. Yes, the Middle East is volatile, but underlying fundamentals remain robust. Capital is rotating rationally out of bloated tech sectors into stable domestic industries. This friction is, building a stronger, decentralized architecture.
Well, I come at it from a completely different way. We are witnessing dangerous fragmentation, and the human and economic costs of this so-called transition are immense, and they are immediate.
In what sense?
In the sense that the breakdown of diplomacy has severe consequences. The effective blocking of the Strait of Hormuz has disrupted 20% of the global oil supply. That isn't just a bump in the road.
It's a significant shock, sure.
It is a massive shock. It is why the OECD, the international organization tracking the world's largest economies, just slashed its 2026 global growth forecast to a mere 2.1%.
Well, forecasts fluctuate.
But the reasons matter. Furthermore, when unilateral actions like sudden 10% tariffs alienate strategic allies from the European Union to Brazil, it creates an environment of global lawlessness.
Lawlessness is a bit of a strong word.
It's accurate, though. This chaos translates directly to human suffering, exacerbating the looming global hunger crisis warned of by the United Nations. And while nations frantically scramble to stockpile critical minerals for this just-in-case economy you mentioned, they are driving up costs and severely delaying the vital planetary energy transition. This is not resilience. It is systemic breakdown.
Okay, let's test that idea of a systemic breakdown by looking closely at the most immediate flashpoint, which is the Middle East.
The perfect example.
Right. We are seeing unprecedented military exchanges between the U.S. and Iran in the Gulf, alongside Israel and Hezbollah's ongoing escalating skirmishes in Lebanon. By the rules of the old economy, this should be breaking the system entirely.
It is breaking the system. Look at the physical reality on the ground.
I am looking at it.
We're looking at a situation where Iran has launched drone strikes toward the Strait of Hormuz. The U.S. military is intercepting them and retaliating against Iranian sites. And Iran is targeting critical infrastructure in Kuwait and Bahrain.
Yes, the region is highly volatile.
Because of this, the Strait of Hormuz, the single most critical maritime oil choke point on the planet, is effectively blocked. The market panic is completely tangible. We watched the Dow plunge up to 900 points, as oil prices and bond yields surged.
For a few days, yes.
But I want to explain the mechanism here. When 20% of the world's oil is suddenly choked off, it doesn't just make gas more expensive, it sends an inflationary shockwave through every single supply chain on Earth.
Right, shipping and fertilizer.
Exactly. Oil goes up, the cost of maritime shipping goes up, the cost of agricultural fertilizer, which is heavily dependent on petrochemicals, skyrockets.
I see why you think that, but let me give you a different perspective. This disruption is actually a necessary stress test for a planetary economy that had grown dangerously complacent.
A stress test?
Yes. Think of the global energy and logistics grid like an over-optimized suspension bridge. For decades, the entire planet has relied on a few critical bolts, like the Strait of Hormuz remaining perfectly peaceful.
Which it rarely is.
Exactly. That is a massive architectural flaw in global logistics. If one bolt snaps, the bridge collapses. The disruption we are seeing right now is finally forcing the world to build more bridges.
Build more bridges. Okay.
It's forcing investment into localized, diversified energy grids and alternative land-based supply routes.
Building more bridges is a lovely analogy, but it takes 10 years to build a bridge, and people have to eat today.
I'm not denying the short-term pain.
Calling it a stress test is a very clinical way to describe a military conflict that is destabilizing an entire region and starving people.
The geopolitical reality is harsh, I completely concede that. But you have to look at how the broader economic machinery is absorbing the blow.
Absorbing it?
Yes. If the global economy were as fragile as the OECD's 2.1% growth forecast implies, a shock of this magnitude in the Gulf should have triggered a global depression. Instead, we see remarkable domestic resilience in major economies.
In the West, maybe.
In the U.S., for instance, job openings are sitting at a robust 7.6 million. And that market panic you mentioned, look closer at the mechanics of it. We didn't see a total market exit.
We saw huge drops.
We saw a healthy rotation. Investors moved capital out of hyperinflated semiconductor and tech stocks like we saw after the Broadcom earnings reports and strategically rotated it into banks, retail, and domestic services.
And why does that matter for the global system?
Because a service-heavy domestic economy is less dependent on imported manufacturing inputs and global shipping. That is the behavior of a market that is absorbing a geopolitical shock, adjusting its risk profile, and stabilizing itself organically.
I'm not convinced by that line of reasoning because you are conflating the financial insulation of Western equities with actual planetary resilience.
How so?
Let's be very clear about the mechanics here. Rotating capital from an AI chipmaker into a Western bank does absolutely nothing to feed the global South.
It stabilizes the core financial system. But you call this an architectural correction, and we have to ask who is bearing the immediate, brutal cost of this transition. The United Nations is issuing dire warnings right now that the prolonged Mideast war is turning a modeled global hunger crisis into a horrifying reality on the ground.
Which is tragic, absolutely.
A wealthy tech investor rotating their portfolio can absorb a 40% increase in the cost of goods. A family in Lebanon or a community in sub-Saharan Africa relying on imported grain cannot.
Right, but
This is a structural failure in global governance. We are allowing a chaotic global leadership vacuum to replace diplomatic solutions with military standoffs, and the fallout is measured in human lives and widespread instability, not just bond yields. But this exact vulnerability, the fact that a family in the global south can be starved because a single waterway is blocked, is precisely what is driving the next major structural shift.
which is?
The aggressive reshaping of global trade. You see a failure of diplomacy. I see the end of a system that subsidized fragility, which leads us to the sweeping 10% tariffs the U.S. has proposed on 60 different trading partners.
Ah, yes, the tariffs.
You framed this earlier as erratic protectionism. I frame it as the creation of a new, ethics-based and resilience-focused market standard.
Ethics-based? A blanket 10% tariff on 60 nations is not ethics-based. It's an economic sledgehammer.
It is the mechanism required to force a change in the supply chain. For too long, the global economy incentivized a race to the bottom.
In terms of labor costs?
Yes, If a nation used forced labor to artificially lower the cost of goods or flooded the market with state-subsidized overcapacity to destroy foreign competition, the global market rewarded them with contracts. You couldn't compete if you played by the rules.
That's a fair criticism of the old system.
Thank you. By instituting a baseline tariff tied to probes into forced labor and unfair practices, you fundamentally change the math. You make the unethical, artificially cheap goods more expensive, which suddenly makes domestic manufacturing and diversified supply chains financially viable again.
So it's a legitimate market correction.
Exactly. It is a legitimate market correction.
I'm sorry, but I just don't buy that. Let me tell you why.
Go ahead.
If these tariffs were a surgical, precision-guided policy targeting specific human rights abuses or specific instances of state-sponsored dumping, we would be having a different conversation.
But they need to be broad to be effective.
But mechanically slapping a blanket 10% tariff on steadfast allies like the UK, Canada, the European Union, and Mexico is not a targeted ethical intervention. It is a blunt instrument that destroys diplomatic trust.
I disagree.
How exactly does penalizing a Canadian lumber export or a Mexican auto part combat forced labor in Asia? It doesn't.
It forces those allied nations to also decouple their underlying supply chains from those compromised origins, because their exports to the U.S. are now being heavily scrutinized.
No, it forces those allied nations to retaliate and decouple from the U.S. dollar system. Look at the immediate reaction from the global south.
Brazil, you mean?
Yes, Brazil's President Lula da Silva explicitly stated his country cannot accept treatment like the proposed tariffs. Brazil is an economic powerhouse and a vital agricultural exporter.
They are.
When you weaponize trade against 60 nations simultaneously, you aren't creating a new ethical standard. You are creating a global trust deficit.
They will adjust.
You are literally forcing sovereign nations to abandon Western financial systems out of sheer self-preservation. You are pushing them into defensive, fragmented economic blocks where trade is based on political grievance rather than comparative advantage.
That's an interesting point, though I would frame it differently. Demanding new terms of trade isn't alienating the global south.
It certainly feels that way to them.
Accountability, and ultimately moving us toward a more balanced, multipolar equilibrium. The era of unquestioned hyperglobalization stripped nations of their sovereign capacity to govern their own critical infrastructure.
Well, that's true.
And it isn't just the U.S. recognizing this. Europe itself is taking very similar steps. The EU trade chief, Maros Sefcovic, is actively pushing back on imported overcapacity.
Right, the tech sovereignty roadmap.
Yes, the European Union is rolling out an entire tech sovereignty roadmap. They are structurally ensuring they control their own digital and physical destiny rather than relying on external actors.
But there is a massive structural difference between the EU developing a tech sovereignty roadmap,
Which is essentially protectionism.
no, which is essentially a system of domestic subsidies and investments to build up their own microchip and software capacity. There's a big difference between that and the U.S. dropping a sudden unilateral tariff that punishes its closest trade partners.
Both are reactions to the same fragility.
One is building domestic capacity. The other is declaring economic war on the rest of the planet.
But the friction of these tariffs is what creates the opportunity for developing nations to rise. Let's look at India.
Okay, let's look at India.
India is the prime example of how this just-in-case transition works to the advantage of the developing world. Because Western nations and corporations are now forced by tariffs and geopolitical risk to diversify away from a single point of failure in China, they are successfully employing what's called a China Plus One strategy.
Right, shifting manufacturing.
Mechanically, this means multinational corporations are keeping a footprint in China, but aggressively building massive parallel manufacturing hubs in India. Capital is pouring in.
It is.
India is drawing in this wealth while fiercely maintaining its own sovereign trade decisions. They are proving that you don't have to be a subservient vassal to one superpower. You can multi-align and win.
Multi-alignment sounds incredibly elegant in an academic policy paper. But in practice, on the ground, it is creating profound economic distortions.
Distortions?
Yes, and this exact dynamic leads directly to our next major reality: Russia, the shifting hub of the global south, and the true cost of this fragmentation.
Let's go there, because the St. Petersburg International Economic Forum, SPIE, perfectly illustrates my point about the rise of a multipolar world.
SPIEF, what some people used to call the Russian Davos.
Exactly. At SPIF, we are seeing the tangible reality of this planetary shift. Russian Finance Minister Anton Siluanov declared a mandate for financial sovereignty.
Against global lawlessness, as he put it.
Yes, explicitly stating they are building institutional resilience against Western global lawlessness. President Putin asserted that the BRICS coalition has formally overtaken the G7 as the primary engine of global economic growth.
Based on purchasing power parity, sure.
And again, look at the mechanics of India's participation. India's successful multi-alignment involves resisting immense diplomatic pressure from the U.S., pressure which Putin rightly dubbed futile, while continuing to secure discounted Russian oil,
which they are refining and selling.
That oil fuels India's domestic industrial boom. At the exact same time, India is actively building the IMEC corridor, the India-Middle East-Europe Economic Corridor.
Assuming the Middle East stabilizes enough to build it.
It's a massive multi-billion-dollar rail and shipping network designed to bypass traditional maritime choke points and connect Indian goods directly to European markets.
On paper, yes.
Indian MP Sujit Kumar publicly commended Russia at SPIEF for treating the Global South as an equal partner. This isn't a chaotic fragmentation, it's the birth of a planetary economic balance, where the Global South finally has significant leverage and a seat at the table.
That's a compelling argument, but have you considered that the entire premise of SPIEF right now is largely a grand facade?
A facade? How?
It is a theatrical performance masking deep structural economic stagnation and severe isolation from Western capital markets. Yes, you have leaders like Tanzanian President Samia Suluhu Hassan attending.
And making real deals.
And you have soaring rhetoric about the Global South rising. But look at the underlying mechanics of what is actually happening. Russia isn't building a unified, egalitarian economic bloc.
They are building partnerships.
They are frantically courting countries like Tanzania to build desperate alternatives to China-led rare earth supplies. This isn't a coordinated, balanced, multipolar order. It is a panicked, uncoordinated scramble by isolated nations to hoard critical minerals.
Why is diversifying the critical mineral supply chain inherently negative? For decades, the entire planet complained about a severe monopoly on rare earth elements.
True. The monopoly was bad.
Right. So now that Russia, various African nations, and Latin American countries are building alternative supply networks and mining operations, we suddenly dismiss it as a panicked scramble. It's competition. It's the market correcting a monopoly.
I dismiss it because of the physical mechanics of how it's being executed. A coordinated, transparent diversification of supply chains stabilizes markets.
And a fragmented one?
A fragmented, nationalistic scramble driven by sanctions, retaliatory tariffs, and the threat of military conflict deeply destabilizes them.
How exactly?
Recent climate and economic analyses show exactly how this plays out. This exact scramble to stockpile critical minerals is drastically driving up the costs of the global energy transition.
Because demand is high.
Because when every nation acts out of economic paranoia, when China, the US, Russia, and the EU are all aggressively hoarding cobalt, lithium, and rare earths, not just for commercial use, but for military applications and national security, the base price of clean energy technology skyrockets.
Materials get expensive, yes.
Solar panels, EV batteries, wind turbines. The materials become prohibitively expensive.
Because the market is finally pricing in the true cost of those materials, which includes geopolitical risk.
But the result is highly inflationary across the board. It means the planetary goal of transitioning away from fossil fuels to clean energy is severely delayed.
It might take longer, but the foundation will be stronger.
Delayed perhaps by decades, because the vital materials are caught in a geopolitical tug-of-war. That isn't building resilience. That is globally detrimental. We are sacrificing the climate transition on the altar of economic nationalism.
You are operating on the assumption that the previous system, where we relied on a highly centralized, often entirely opaque supply chain for those green transition minerals, was sustainable.
It was cheaper.
But it wasn't sustainable. The inflation we are seeing right now in critical minerals, the friction in global trade, the diplomatic maneuvering, this is the cost of pricing in reality.
It's a very high cost.
The old global order was a house of cards built on unpriced risk. Yes, rebuilding an energy grid after a blackout is expensive. Building duplicate supply chains through a China Plus One strategy is expensive.
Extremely expensive.
But the long-term result is a robust, distributed system where no single nation and no single maritime choke point can hold the global economy or the energy transition hostage. We are moving from a system of brittle efficiency to a system of durable resilience.
But durable resilience requires trust. And trust is the very currency that is being systematically destroyed here.
Trust in what? The old system?
Trust between nations. You mentioned the EU's tech sovereignty. You mentioned India's multi-alignment and the IMEC corridor. Let's think about how these interact.
Okay.
What happens when India's China Plus One strategy collides with the new U.S. blanket tariffs? What happens when Europe's sovereignty roadmap leads to a massive retaliatory subsidy war with Washington?
There will be friction.
When the U.S. targets 60 nations with tariffs, when Russia and BRICS try to build parallel financial messaging systems to escape the U.S. dollar, when the Middle East's most vital waterways are choked by drone strikes, we are not building a diversified, resilient grid.
What are we building then?
We are building walled gardens. We are building fortresses. And if you look at economic history, walled gardens inevitably lead to localized poverty and broader conflict.
That's a very pessimistic read.
The OECD isn't cutting global growth to 2.1% because the system is getting stronger and more resilient. They are cutting it because economic warfare inherently destroys value.
Value that was largely illusory to begin with. The shift in capital markets rotating into fundamental sectors. The tariff realignments, forcing absolute accountability in labor practices.
We're trying to anyway.
And the rise of a multipolar system where nations from Brazil to India dictate their own economic destinies rather than waiting for permission. This is the sound of that centralized, vulnerable order being dismantled.
It's a very loud dismantling.
The volatility is undeniable, I won't argue that, but it is the necessary friction of progress. We are forging a planetary architecture that actually reflects the true distributed balance of power in the 21st century, rather than the unipolar illusion of the 1990s.
I see the dismantling very clearly, but I do not see the progress. The dismantling of diplomatic and economic norms is yielding disastrous, tangible results today, not in some theoretical future.
In certain sectors,
we have choked waterways in the Gulf, disrupting 20% of the energy that powers the world. We have alienated our closest allies in Europe and Latin America through erratic, blunt force tariffs.
Blunt but necessary.
We face lowered global growth, inflationary spirals in the exact critical minerals we need to save our climate, and impending humanitarian and hunger crises that far outweigh the seminar room benefits of multi-alignment.
I hear you.
When you replace the established rule of law with the raw rule of leverage, it is always the most vulnerable populations on the planet who pay the ultimate price.
Well, we can certainly agree on one fundamental, undeniable reality. The era of uncontested, single-power dominance is definitively over.
Absolutely.
The tectonic plates of the global economy have shifted, and the geopolitical landscape has been permanently altered.
Yes, that era is behind us. The unipolar moment is gone. Where we fundamentally diverge is on what takes its place.
Exactly.
You look at this friction and see it stabilizing into a new, functional, multipolar balance of power. I look at the data and fear we are descending into a state of perpetual economic warfare and regionalized conflicts, where trust is simply too broken to build anything truly resilient.
And that is exactly what we will be watching unfold as global supply chains, capital markets, and diplomatic channels adapt or fail to adapt in the coming months.
It's going to be a turbulent year.
Definitely. There is much more to uncover regarding how these massive structural shifts will materialize on the ground, from the ports of India to the markets of Brazil. As always, we leave it to you, the listener, to examine the evidence, weigh the mechanisms at play, and form your own conclusions on the future of our planetary economy.
Thanks for listening.
Remember, when the tectonic plates of history snap, it's rarely quiet, but it's how the new landscape settles that defines the era to come. Thank you for joining us.
That's it for today's Artificially Informed.
Nope. Thanks for spending your time with us.
Yeah.
Stay sharp, stay curious. See you next time.